Hi, so now we're ready for section 4.2, graphs of exponential functions. They want us to start off by just graphing these kind of generic exponential functions by plotting points. So in this first one here to the left, let's make an XY table and plug in values -2, -1, 0, 1, and 2 for our x values. So if we plug in -2 for our exponent, remember a negative exponent means reciprocal. So that would give us a 1/4. 2 to the -1 is 1/2. 2 to the 0 power is 1. 2 to the 1 power is 2, and 2 squared would give us 4. So what would this look like if we graphed it? So x is -2, 1/4, -1, 1/2, 0, 1, and then 1, 2, and 2, 4. Notice how it starts to increase pretty quickly. So if we're to graph it on just that side of the points, notice how it increases. But the question is, as the graph goes to the left, will it ever be 0 or negative? In other words, is there any exponent that if I took 2 to that exponent, would it ever be less than or equal to 0? The answer is no. Notice when we plugged in 0, we got a +1. When we plugged in a -2, we got a +1/4. Those negatives only change the position. It takes the reciprocal. So this function will continue getting closer and closer to 0, 1/4, 1/8, and so forth, but it will never actually reach 0. So this would be a no. Let's take a look at the next one. Here, our base or our factor is 1/2, so we have a decay factor. We create an XY table. Let's use the same x values. -2, -1, 0, 1, 2. Again, the negatives mean reciprocal. So if we take the reciprocal of 1/2 and square it, we would get 4. 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. And 1/2 squared is 1/4. So what does this look like when we graph it? We have -2 up here at 4, -1 at 2, 0 at 1, 1 is at 1/2, and 2 is at 1/4. And it's the same concept, just decreasing instead of increasing. It will never hit 0 or become a negative unless there's some vertical shift. So these are parent functions. We're not adding anything to it. There's no a in the front. So all of those generic functions would look similar to these two. So we want to take a look at the characteristics of the graphs of this parent exponential function, f of x equals b to the x, when the base is greater than 0, but doesn't equal 1. Try to minimize that so you can see both at the same time. Are these functions? Yes, they pass the vertical line test. They're also one-to-one functions, so we can deal with inverses. They both have a horizontal asymptote at y equals 0. There is no vertical asymptote. The domain, we can plug anything for the x, so it goes from -infinity to infinity, but the range starts right after 0, so we're going to use parentheses 0 all the way up to infinity. There are no x-intercepts, since it doesn't cross the x-axis, and the parent function has a y-intercept at 1, so we get a 0, 1 as our y-intercept. It's increasing over the entire domain from -infinity to infinity if b is greater than 1. In other words, it's more than 100%. It's decreasing on its entire domain, -infinity to infinity, if our b is between 0 and 1. We do not have a local minimum or a local maximum, nor a global min or max, and we have end behaviors for both. If b is greater than 1, in other words, it's increasing, then as x is approaching -infinity, y is approaching 0, and as x is approaching +infinity, y is also approaching +infinity. The end behavior for a decreasing exponential function, in other words, your factor is a decay factor between 0 and 1, then it's backwards. As x is approaching negative infinity, y is approaching infinity. And as x is approaching positive infinity, y is approaching 0. You don't have to memorize all of these, but it's good to review what is in behavior, what is increasing, what's domain and range, and just kind of give you an idea of what these generic equations look like. So when you do have a transformation, you're able to graph it.